In section 7.2, we start to tackle the different elements of the hypothesis test that we just talked about. And the first thing we're going to tackle is this question of formulating hypotheses. So our first goal is to say, how do we do a good job of formulating hypotheses, and how do we choose these productively? As you learned last time, we have two hypotheses. We have the null hypothesis, and then the other one we're going to call the alternative hypothesis. The null hypothesis, we're always going to write the same way. We're always going to write it as H naught, and then we'll have mu is equal to some number. And so your null hypothesis is always going to look like this. Now, please don't put a number sign or a hashtag on your problem. This number, this is going to be an actual number that shows up in your problem. So what is the null hypothesis? This is the average, the population average, if nothing interesting occurs. Okay, so what do I mean? So in the other last time I spent a lot of time talking about a medical example. So if you're a doctor and you're studying some sort of new medication, this number would be the average, like the average rate at which people get better without any medication. So this is what you would expect to happen if the medicine does nothing. If nothing interesting happens, the medicine does nothing. This is the number that you would expect. If, for example, you're studying a business and you've tried something new in your business, this is the amount of revenue you would expect if your new experiment does nothing. So if nothing happened, this is the result you would have. Now, our alternative hypothesis, we're going to write with an H, and we're going to put a little A on here. By the way, sometimes I'm going to use 1 because whenever I learn statistics and in some of my other classes, we use H1 here. If I do that, forgive me. HA is how your book does it, so I'm going to try to be disciplined and stick with the same notation. So HA, we're going to look at one of 3 possibilities. Either we're going to write that our average is bigger than whatever that number is. We're going to use the same number. Or we're going to write that the average is less than whatever that number is. Or we're going to write the average is not equal to whatever that number is. Now, which one we choose depends upon choose one. So whichever one you choose depends upon the problem and depends about what you're trying to prove. So if you are trying to prove that people, if this is the amount of time it takes someone to heal, then you're hoping that your medicine makes that amount of time become slower. So you would hope that, so less than would be the one that you would choose. If however, this is your revenue and you're hoping that your revenue, that your new business decisions increase your revenue, you would do greater than revenue. If you're just interested in detecting whether something is different than it was before, you might use this third one. So choose one, and the one you choose depends upon what you're hoping to prove. This is what you are testing. So how are your problem sets up? This is the test that we're going to go for. Okay, we're going to do exercise 7.1, and we're going to look at all 3 of these. So let's start with A. If you felt like that problem made a lot of good sense, then now would be a good time to pause your button, read A, B, and C, and see if you can write down what you think these hypotheses are for these problems. If it's still a little murky, then maybe we'll watch A, and then we'll have a chance to pause after that. Okay, well, if you pause your screen, good luck. I hope that our numbers match up. If not, let's read this together. A teacher believes that students will average a 78 on a standardized exam. However, he believes that students at his school are exceptional and that their average on the exam will be better than the national average. So what's our null hypothesis? Our null hypothesis is that the students in a school, that nothing is happening, that the students in a school are the same as everyone in the nation. So If there's nothing different about his school, then what would we expect the average to be? We'd expect the average to be 78. So mu equal to 78 is what I would expect. Now, however, he is hoping that his students are exceptional and that they will score better than the national average. So what would be better than the national average? Our alternative hypothesis, which is what we're hoping to prove, is that our students are actually greater than 78. So this is what we got for the first set. This is our null hypothesis. If nothing is going on, our students have an average of 78. Our alternative hypothesis is if our students are exceptional, then it's greater than 78. Okay, let's move on to part B. If you didn't pause your screen earlier, now you should definitely pause your screen, and you should definitely take a moment and try part B and part C and see if you can start to write down these hypotheses. So pause, give yourself a go on these last two problems before we talk about them. Okay, part B, a track star averages 53.54 seconds in the 400-meter dash. That's a lot faster than I ever ran the 400 meter. I ran in high school, but I went to a school that was kind of obsessed with football, and our track team wasn't very serious. In fact, we would just kind of do football training drills all week. And then on Saturday, we'd show up to the meet, and I didn't even know what event I was going to run until I showed up at the meet. I realize now this is not the way a good track program runs. I ran the 400, but I never ran very fast. I was always just under a minute on my 100s, on my 400s. Okay, well, a track star averages 53.54 seconds. She tries a new off-season training regimen and wants to determine if her average time got faster than her previous time. So our null hypothesis is that the training regimen did nothing. If the training regimen did nothing, then her average is still going to be 53.54. However, if her training regimen worked, what would we expect? We'd expect her to get faster, and in time, faster means that it's less than, because if she's faster, then less than 53.54 is what she got. Okay, let's move on to part C. A scientist notices that something's not quite right with his weekly pasta dinner. He wants to test whether the average amount of sodium in his pasta is different from the recommended amount of 3 milligrams per cup. So the scientist is a little bit eccentric. Maybe that's normal for a scientist. Okay, so our null hypothesis here, if there's nothing going on with his pasta dinner, the sodium in his pasta dinner is exactly normal, exactly what it expects, then the sodium would equal the recommended 3 milligrams per cup. However, our alternative, oh, I forgot to write my A. Notice, see, I told you I was going to write 1 sometimes because that's the way I learned it. Okay. Our alternative hypothesis is going to be that there's something different. But notice, our scientist doesn't distinguish the difference between having, he's not testing if there's more sodium, he's not testing if there's less sodium, he's just testing, is the sodium different? And so different, we're going to write mu is not equal to 3 milligrams per cup. All right, so that's how we write hypotheses. Try out the homework problems, and it'll give you a bunch of examples to go through these null and alternative hypotheses and think about them. At the bottom of your notes page, you'll see we talk about type 1 and type 2 error. This isn't going to be a big deal, but let me just say real briefly what it means. Type 1 error is whenever you fail. Okay, let's see. I hope I get this right. Type 1 error is whenever you fail to reject a hypothesis when it's really wrong, and when it's really wrong. And the type 2 error is where you reject a hypothesis when it's really not wrong. So type 1 and type 2 is just the different ways in which you could be wrong in your hypotheses. I hope I got these right. I always get those backwards, so I hope I didn't get them backwards right there for you. This is not a big deal, but just know that there are 2 ways you can mess up on your hypothesis. One, your hypothesis could actually be false, and you didn't figure out it was false. And the other option is your hypothesis could not be false, and you found it to be false anyway. In general, we consider the second option much more concerning, because if something is false and you don't find it, then you haven't come to any great conclusions. You haven't rushed out and told the world that you discovered something interesting. You've just kept with the status quo. And so that's not near as big a deal as the second time whenever something is found to be false that's not really false. and then you kind of often will make a conclusion, and that conclusion is actually wrong. So type 1 and type 2 error is how people refer to these things. And again, it's not a big deal this semester. It's just ways in which your test can go wrong. So good luck with that. We'll come back pretty soon and start talking about our test statistics and our p-values.